Hello, my name is Guillaume. I'm a Canadian pension actuary and the author of the Actuarial Excel Addin. The Actuarial Excel Addin adds functionalities to Excel workbooks to perform simple and complex actuarial valuation of pension plans and pension plan administration tasks like calculation of benefits, preparation of benefit statements, and preparation of annual statements. Since 2005, the add-in has been used by actuaries and pension plan administrators. Trial of the actual Excel add-in is available for free at the address appearing on screen. Welcome to this video, part of a growing series of tutorials. So let's turn off the camera and start the tutorial. I hope to see you there. Welcome to this tutorial about the LX function. LX comes from the actual notation and it represents the number of lives surviving at age X, starting at 1 million at age 0 and going down with mortality at age 120. The LX function will return a vector of LX values from age 0 to 120. The LX function is never used alone, but always as a parameter of other functions like the JS functions for annuity factors, the TQX functions to calculate the probability of mortality, and TPX for the probability of survival. Let's go through the list of LX parameter first in the green box. So I've prepared here two lists, one for an annuitant, LX1, and LX2 for a co-annuitant. So first parameter is the sex. Sex is either 1 for a man and 2 for a woman, and anything in between will be a prorate. So 1.25 would mean 75% of the mortality rate from male and 25% from female. The only required parameter. All others are optional. Then the QX table, the mortality table, I put CPM 2014 here. The default value is up 94 ICA. And if we go to the list or short list of mortality table, it's not all tables are represented here, but you see we start with CPM 2014, the Canadian pensioners' mortality based on a study from the Canadian Institute of Actuary in 2014 of registered pension plans. The same table have its private sector plans equivalent, CPM 2014 PRIV, and the public sector pension plans, CPM 2014 PUBL. These are in column B. These are the names you would have to refer to in the LX function. And you also have some census mortality table for Canada 19, based on a study from 2017 to 2019, and the equivalent table for Ontario and Quebec, and also a period life table for United States of a study in 2017. Further down, we'll look at them right now. You have some projection scale, and their name, as known by the add-in, is in the column B. So you have some scale, 2D scales, where mortality rate will be projected by age and by year. The one that is currently used often is the CPMB, and its name is ECH underscore CPM underscore B. You also have the MI 2017, and you have a list of 1D, one dimension projection scale, the ECH underscore AA, etc. So going back to the, okay, so next parameter is age move, and age move is a shift in the mortality table. It's an integer, it must be an integer, plus or minus. If I use plus 3, it would mean that I move my rate 3 years older. Like if I have a person age 35, the first mortality rate will be at age 38. If it's minus 3, the same person at age 35, the first mortality rate would be at age 32. So it's either plus or minus. And if I put 3, for example, you'll see that the TQX here in that box will increase because it's older, and if it's minus 3, TQX, which is the probability of death, would be reduced. Next parameter is the loading parameter. So the mortality rate could be loaded from minus 100% to whatever you want, with the limit that the final mortality rate will be limited between 0 and 1. Could not exceed 1, could not go below 0. So if I load by 100%, it would mean 2 times the mortality rate. And you see the rates have been multiplied by 2. So if I put it back to 0. Next in the box are the parameters for the projection of mortality rates. By default, there's no projection, so the default value of the projection parameter is false. If I want a projection, I put the parameter to true, and then I have to indicate what is the projection scale I'm using, what is the projection base year for the mortality table, what is the year of the valuation, what is the age at valuation of the person I'm looking at. So projection base year, here I'm using the CPM 2014 table, so the projection base year would be 2014, and I'm currently in 2021, so that's the year of valuation. And age at valuation, I assume that's the same as the age that I've entered here in my parameters. So my annuitant, for example, I've used 57 as his age, and it would also be his age at valuation. And I've find the equivalent for the LX2, which would be the parameters for my co-annuitant. So now we'll look at how the LX is used by add-in functions like JS. As I said, LX is never used alone. It's used as a parameter of another add-in function. So here, for example, in JS, where I'm calculating an annuity factor for a person age 57, a female, with the co-annuitant being a male age 60, with 50% reverting to the spouse after the annuitant's death. And my interest rates are a vector of 3% per year for the first 10 years and 3.5% thereafter. So my GS function, if we go looking at the parameters, we have age 1, 57, interest 5, age 2 at 60, and reversion at 50%. If we want to look at the LX parameter, position ourselves in the cell of JS, then position our cursor somewhere in the LX, among the LX parameters. And if I click on FX, the list of the LX parameters appear here, and they're just what we've seen before. So that's how you include an LX within a JS function, and there's two of them because there's the LX for the annuitant and the LX for the co. So we have a LX here and we have another LX here. So if we go to the second LX, we have sex2, QX2, age move 2, load 2, project 2, etc. These are the parameters that we find in that column. So that concludes the tutorial, and I hope to see you soon. Bye.